question 2 says to us that consider the following sequence. Now things get to be interesting now, because here they just say consider the following sequence, that we are not told what sequence this is, and we are given here that the sequence is actually, we are on question 2, the sequence is actually minus 7, 0, 9, 20, and the sequence goes on like that. A very interesting sequence actually when you look at it, because you can't see an obvious pattern here. I don't know if you guys, when you're looking at it, are you able to see an obvious pattern? But as usual, because at this stage we know two types of sequences, arithmetic and geometric sequence, we are going to test to see if we do the difference between the successive terms. In other words, between term 1 and term 2, what actually do we get? So that is to say term 2 minus term 1. So that is like saying 0 minus a 7, right? Remember here I'm going to have a 0 minus, and then we have a minus 7 as well. This would give me a 7, right? And I'm going to do the same thing also here by finding the difference between term 3 and term 2, right? So I'm going to say term 3 minus term 2. That would then say to me that we have a 9 minus a 0, right? Remember, a 9 minus a 0 actually is just a 9. Minus 0 here is just going to be a 9. So we're going to have a 9 there. Then I'm going to also do the same thing to say T4, term 4 minus term 3, right? Which is a 20 minus a 9. And 20 minus 9, we all know that it should give us 11. Remember, you can use your calculator to save time, especially if you can, compute these numbers in your head. Now, here we can see that we don't have a common difference, so this cannot be an arithmetic sequence. So that means I can continue to find a difference of the first difference, right, to see if we have the second difference. Now, if we say 9 minus a 7, that gives us a 2. And if we say 11 minus a 9, it's also giving us a 2. Now, we seem to have a constant second difference here, right? And we then call this type of a sequence a quadratic sequence. That means after considering this sequence, we were able to deduce that this sequence is a quadratic sequence. Now I'll be able to answer the questions. Question 2.1 says determine the general formula for this sequence. So we are looking for Tn, a formula that we can use to find this sequence, any term in the sequence. Because remember, we know that n is a function of our quadratic equation that we were dealing with in a quadratic sequence. Now to do this, I'll say the first term is really defined, well, not the first term, but the common difference. The second common difference is a 2 and is equals to 2a, right? And now we then can see that a is equals to 1, because when we divide both sides by a 2 here, this and this cancels. This would give me a 1. We also know that the first difference, meaning if I take term 2 and I subtract term 1, I always get a 3a plus b. But we know that this difference, this first difference in this specific sequence is a 7. So that means here I'm going to have a 7, because if I say term 2 minus term 1, I get a 7. But we're saying that in general, it should always be equals to 3a plus b. And so this means now here I'm going to have a 3, but we're saying our a is 1 and we have a b here. So this would mean that my b should be equal to, I see a 4 here, because here I'm going to have a 3, and then we are saying 7 minus 3 when I take the 3 to this side, so that now I have a 4. We also know that the first term in a quadratic sequence is always defined as a plus b plus c. And our first term here in this sequence is actually minus 7. So here I'm going to have minus 7 is equals to a, we said is 1. B, we just said is 4. We calculated these two here. And we don't know the c. Now this means our c is actually going to be, so here I have a 5 and I take it to this side. Now I'm going to have a negative 7, negative 5. And negative 7 and negative 5 should give me a negative 12. Now at this stage, I'm going to take my formula of a quadratic sequence, which is given by the an squared bn plus c. And I'm going to say here that our a is 1 and we have n squared. Our b is 4 and we still have the n there. And we just said the c actually here is going to be minus 12. And this would simplify indeed to an n squared plus 4n minus 12. And this actually is our general formula for finding any term in the sequence. N here is a function of Tn. If you put the values of n there, we can get any term in the sequence. And of course, it's a function that's restricted for natural numbers, because n can only be natural numbers, the counting numbers. Now, this question, it is 4 marks. As you would have recalled from the first question that we did, 1 mark for finding A, 1 mark for finding B, and 1 mark for finding the correct C. So already we have 3 marks there. The last mark really would be you finding or putting all those numbers correctly to find the nth term or the general formula. The last question, 2.3, says that which term in the sequence is 48, right? So we want to know which term in the sequence is 48. So this means here we're saying that I'm going to write here 2.3. We are saying that if we're looking for some term Tn that will be equal to 48, right? But now that term, we don't know what is n, what is the number of terms. That means here we have to find a number of terms to know that which term, which term will this be, right? Which term will this be? What is the number of terms there? Will it be the 10th term, the 15th term? That will give us 48. So we're looking for the number of terms, n. Now, this is a really easy question to compute, because what we're going to have here is that we are going to use our general formula here to say Tn is equals to n squared plus 4n minus 12. And we are saying here that our Tn is actually equals to 48. And we still have n squared plus 4n minus 12. Now, at this stage, this question becomes very, 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 very boring, because we all know and can see that this is what we did in algebra. This is like solving for x, except in this case, we're solving for n, really. And as usual, when we solve this type of questions, we'll take the 48 to this side, so that I'm now having n squared plus 4n, and here we're going to have negative 12, negative 48. Remember, the 48, when it goes that side, is going to be a negative, and we can clearly see that negative 12, negative 48 will give us a negative 60 here. So that means here I'm going to have minus 60, but this side I'm going to have a 0. Remember, when I take this to this side, I'm going to have a 0, it will disappear. It's more like I'm actually here subtracting 48 so that I get a 0 this side. And this side, I'll do the same thing. What I do on the left, I also do on the right. Now, from here, I think we can factorize this. We can break this into two factors to say it is equals to 0. Obviously, here we're going to have the n and the n. And the factors that naturally come to mind for me, it will be a 10 and a 6, because I know that 10 times 6, it actually gives me a 60. So I'm going to try those ones to say I have a 10 and a 6. And we can see that if we, maybe let me write this down on the side. Remember we're saying the factors here that we're dealing with are a 10 and a 6, right? If we multiply these two, we get a 16. Now, just to then now find the signs here that we have to put, I'm going to say if I say 10, minus 6, I see that I get a positive 4. Do you see that when you say 10 minus 6, we get a positive 4? It is this 4 here. But if I multiply the 2, if I multiply 10 minus 6, I get a minus 60. So this tells me that my 6 should be negative. My 6 should be negative and my 10 should be a positive. So now here I'm going to have a positive 6 and a negative 6 here, right? And this becomes easy to then find the final answer because n would be negative 10 or n would be a 6. However, remember n has to be an element of integers. No, it has to be an element of natural numbers, right? It is only allowed to be the counting numbers. So n can never be a negative 10 like this. So we're going to reject that answer to say n should never be equal to a negative 10. And in fact, the correct answer would only be this one. N has to be 6 because it's one of the natural numbers. It falls under the natural numbers. So now this means we have found the number of terms to be a 6. This would mean that at term 6, when we are at term 6, we get the 48. And one can actually go test this. You can take this 6 and put it here in your general formula to see if it satisfies this equation. If it makes this equation to be true, you must get the 48, not 46. Now this question is 3 marks. So how are they going to mark this one? So here you will get a mark for the standard form for writing the standard form on this equation, meaning simplifying all these things and coming to a standard form. They give you a mark for that. And they also would give you a mark for actually computing this, for being able to set up this equation, because you have to be able to see that Tn in this case is 48 and we have that general formula. So they award you a mark for that. And of course, the other mark will come for writing the final answer. Now, writing your final answer also includes rejecting this answer, right? If here you didn't reject, this thing will be wrong, right?